Hi, Timothy Pearson here from Raptor Engineering, here to demonstrate Kestrel, the world's first soft BMC solution. Kestrel is built on Lattice FPGA technology, the ECP5. It is paired with hardware from Raptor Computing Systems, the Talos 2 mainboard here, using the IBM Power 9 CPU. Everything you see here today in this demo is open source, from the firmware running on the Power 9 CPUs, the mainboard, to the actual Kestrel BMC itself. The Kestrel BMC is actually running on top of the Arctic Tern module from Raptor Computing Systems as well. This is a small SODIMM form factor device that contains all the functions required for a BMC. So it contains the FPGA in our case, it contains the DRAM, it has HDMI, it has onboard flash, and it has Ethernet, all on this single SODIMM size card. We then take this card, we break it out into multiple connectors to attach to our existing Power 9 hardware, and we are able to bring this entire server online using all of the open source components. We do not require the A-speed, and we do not require any proprietary firmware, tooling, or other software in order to do this. The IBM Power systems are more difficult to boot than your average Intel, AMD, or ARM server. So this is an excellent showcase for the technology. We actually use something called FSI for instance, to communicate with the power processor during the boot sequence. This is a very complex high-level protocol that we are actually able to push down into FPGA fabric to greatly accelerate all of the communication between the BMC and the host. Similarly, we can push a lot of the access from the power host to the SPI flash, which normally has to be translated and routed over LPC. We can push that down into FPGA fabric, and we can use DMA. We don't have to involve the host CPU in all of these transactions, again, yielding a significant boost in performance. But really the key thing here is security. Because there is no hard ASIC and there is no proprietary firmware, there's no closed source boot ROM, there's no tooling in binary form only that you just have to trust. This system is 100% completely auditable. If there's any issue discovered in the HDL that's actually driving all of the interfaces between the BMC and the system itself, those can actually be patched out, whereas if you had an ASIC, you would actually need to do another spin of the silicon. Maybe you have to live with the security vulnerability. Maybe you have to replace all of your hardware. So from our perspective, this type of solution, especially when combined with standardized technologies like the Power ISA, which runs both on the host CPU and the soft CPU on our FPGA, this is the path forward for secure systems in the future. Thank you.